Okay, so we're going to take a look here at a scenario in which we have another drum. We're going to be raising up a block with it, and this time we're trying to find the angular velocity of the drum, so how fast that drum is rotating. Previously we found how many rotations it had. There's a slightly different example too. So we're going to say the drum is lifting the bucket 10 meters in 5 seconds. So I mean, there's really a couple ways you could approach this. We know that there's a relationship between velocity, angular velocity, and the radius. We could use that. Or we could say, if we know the number of radians, then we divide it by the amount of time, that will give us the angular velocity too. So we have two approaches. It's really, they're both just as good as each other. In some cases, probably this one will be a little more easy, or a little easier to use, and in other times this one might be. So either way, we know that the radius is equal to 20 centimeters, or 0.2 meters. And if we're going to go a distance of 10 meters in 5 seconds, that's going to give us a velocity, a linear velocity of 2 meters per second. So if we want to use that first equation, we say that 2 meters per second equals omega times our radius of 0.2 meters. We divide the 0.2 over, and we get that omega is equal to 10 radians per second. Okay? And we can do that another way. Using this equation, we can say, okay, the radius is 0.2 meters. We're going to go a distance of 10 meters. And so, using this one right here, S equals theta times R. 10 meters equals theta times 0.2 meters. We divide that over and get a theta of 20, no, 10 divided by 0.2 would be 50 radians, sorry about that, of 50 radians, okay? And then we can go over here and say, okay, well, omega is going to be equal to the number of radians divided by our time of 5 seconds. So anyway, 50 radians over 5 seconds going to give us our 10 radians per second. Again, so we can also find our angular frequency, or our frequency, because remember that omega is equal to 2 pi times the frequency. Okay, and so if we say, that would mean that frequency is equal to omega divided by 2 pi. And so we're going to say 10 radians per second over 2 pi radians to convert that to revolutions. And so we get the frequency to be equal to about 1.59 hertz. Alright? And so we've used our equation that kind of equates angular and linear velocity, and our equation relating angular position and distance, and then our equation, I guess this would be angular displacement over time, is equal to our angular velocity. Okay? And so we will continue now with acceleration. Okay, before I continue with acceleration, I just want to point out one thing that I just kind of noticed as I was showing that previous part. I was referring to frequency as angular frequency, and it's not. So frequency is just frequency. And as we said before, it's the number of revolutions divided by the time. And then we have angular velocity, which is the number of radians divided by the time. Okay, angular velocity can also be called angular frequency. Okay, and so previously I was referring to this as angular frequency when it's just frequency. This can be called angular velocity or angular frequency, and you may have seen it used as angular frequency, maybe in your trig class, or I guess your pre-cal class, something like cosine, maybe amplitude times cosine, omega t plus phi, or something like that. And this would be angular frequency in that case too. Okay, so anyway, here we have it's another question with the same situation in which we have a block being lifted from rest, and it's going to lift until it has an angular velocity of 16 radians per second. So we kind of have like an initial angular velocity of 0 because it started from rest, and then it's lifted until it has an angular velocity of 16 radians per second. This takes a time of 4 seconds. Okay. Information not given is the radius. Let's say the radius of the block is 20 centimeters, okay, which would be 0.2 meters. Alright, so anyway, given these three pieces of information, we can solve for angular acceleration because it is the change in angular velocity divided by time. Okay, so that change would be 16 radians per second minus 0 radians per second all over your 4 seconds, giving us 4 radians per second squared for our angular acceleration. Alright, well, it's also asking for the acceleration of the block, which would be the linear acceleration. Well, we can do this too because we know that, let's see, okay, so acceleration is equal to alpha times r. So anytime again that we have the angular quantity, if we multiply by the radius, we get the corresponding linear quantity. So if we have an angular acceleration of 4 radians per second squared, and we multiply by our radius of 0.2 meters, that's going to give us an acceleration of, I guess that would be 0.8 meters per second squared for the acceleration of the block.